Hello, YouTube. This is Mr. Bakari, and today we're going to look at DeMoivre's theorem, and specifically the part where we find complex roots of a complex number. Okay? So, what we're going to do here is I'm going to create a concrete example for you to kind of show you exactly what this means. So, our first problem says find the third roots of 8. But before we do that, we're going to back up a minute here. Let's look at the square root of 81. Well, I know that there are two square roots of 81, 9 and -9. Okay? Now, if you read this statement, which comes from the fundamental theorem of algebra, it says every non-zero complex number has exactly n distinct nth roots in the complex plane. Now, 81 might be a real number, but we know that all real numbers can be written as complex numbers. And as you can see, if we take the square root, we have two roots. And that's what this statement states. So if you're going to find the cube root of a number, what that means is you will have three roots. Now you might be saying to yourself, the cube root of 8 is 2, and you would be correct. But what this tells us is there are two more. So the fact that there are two more, and we only know two off the top of our head, tells us that these other two are complex roots. Okay? So what I'm going to do is show you how you find those other cube roots of 8. All right? So the first thing we want to do is we want to start off in trig form. So I can write 8 as 8 CIS 0 radians. Okay, so that would be 8 in trig form. And I'm going to find all of the cube roots of that. Okay, I already found one, which is 2. And if I write 2 in trig form, that would be 2 CIS 0 radians. Okay? Now, to show you where I got this information from, over here I've got a complex plane. This is the real axis, and this is the imaginary. So if I want to graph the number 8, it would be on the real axis way over here. So I would graph it, let's say it's right about here, 8. So my root is 2, which would be right about here. So there's 2. And as you can see, the angle of 2 is 0, and the angle of 8 is 0. Okay, so in trig form, our first root is 2 cis 0 radians. Now, let's talk about how we find the other roots. What's important to understand is that these roots are evenly spaced around the complex plane. And if we're taking the cube root, we know we have 3. So how do we evenly distribute 3 roots around a plane that is 2 pi? We take 2 pi divided by n. And in this case, n is 3. So we get 2 pi over 3. And what that tells us is that 2 pi over 3 from our first angle, we will have another complex root. And then 2 pi over 3 from there, we will have a third and final complex root. So now we have our 3 evenly distributed roots. Okay? Now, to find those roots is very simple because we all know that we're writing these in trig form, and the trig form is r cis theta. So we need to know how far are we from the origin. Well, these are all 2 away from 0. Remember, they're evenly distributed. So that means my second complex root is 2 cis, and theta is 2 pi over 3. And my third root is 2 cis, and theta is 4 pi over 3. And those are my 3 cube roots of 8. Okay? What that means is if we were to cube these, they would all give us back 8. So that's what we're doing here. Okay. So now we're going to look at another example. But before we do that, I'm going to lay out the 5 steps for you. So you're not going to need to draw this picture every time you do this. So what you need to be aware of is the 5 steps. So step 1 is to take the complex number that's given to you and write it in trig form. Okay. Step 2, we're going to find the nth root for r. So you're going to take r of your complex number and find the nth root, which will be in the question. 3, we're going to find the first angle by taking theta and dividing it by n. And then we're going to find the other angles by repeatedly adding 2 pi over n like we just did. And then you write out all your answers in trig form. Okay, so I'm going to walk you through an example. All right, the question says, find the indicated roots of the complex number. Find the fourth roots of 16 times cosine pi over 3 plus I sine pi over 3. Now, I was using the shorthand before, so if I write this in shorthand, it will be 16 CIS pi over 3, okay? And I'm going to find the fourth root. So remember, what does that mean? There will be 4 roots evenly distributed around the complex plane, all right? So 4 roots, 4 answers. So I'm going to write Z1 for my first root, Z2, my second, Z3, and Z4. All right, step 1, write Z in trig form. It is already given to us in trig form, so we'll go right on to step 2. Find the nth root for R. So here is R out in front, 16. And we're going to find the nth root, which is the fourth root. The fourth root of 16 is 2. So all of our roots, R is 2. Now I'm going to write this CIS, shorthand form. And now all I need to do is find the angles where they are evenly distributed around the plane. So to find my first angle, I take theta, which is right here in my complex number, and I'm going to divide it by n, okay? So we have theta divided by 4. So to divide 4 is to multiply by a fourth, and you can see that our first angle is pi over 12. All right. Now, to find each additional angle for the remaining roots, we take 2 pi over n. So 2 pi over n, which is 4, is just pi over 2. So what that means is pi over 2 from pi over 12 is our second root. Then we add pi over 2 again, and we get our third. We add pi over 2 again, and we get our final root. So I'm going to look at pi over 2 as 6 pi over 12 because I'm adding it to pi over 12. So that means my second root will be at 6 pi over 12 plus pi over 12, 7 pi over 12. My next one will be 7 pi over 12 plus 6 pi over 12, 13 pi over 12. And then finally, 6 pi over 12 and 13 pi over 12 is 19 pi over 12. So these are all of my fourth roots of 16 cis pi over 3. Okay? So again, if I were to raise these to the fourth power, I will get back my complex number here that I started with. And that's finding the nth roots of complex numbers using DeMoivre's theorem. So I hope this helps you out, and I will see you in the next video.